Hi, good evening, and welcome back to Math Business Applications. I'm Amy Fuchsteiner, your instructor for this course. We are currently working in Unit 7. This is Chapter 11, Compounded Interest and Present Value. Today, we're working on the second section in compound interest, which is Chapter 11, Section 2. We're going to be working on the present value of compounded interest, and as such, we're going to be determining the present value of a future goal. We're going to use, first of all, the present value table, meaning we'll need to be able to find the interest per period, the number of compounding periods in a year, and totaled for the loan. We're going to use those to find a table factor and calculate the present value, and then separate the interest in that account from the compounded amount and from the present value of the account. We want to be able to calculate a new table factor, one beyond the table that you have access to, and we want you to be able to use the present value formula. That means you have to be able to identify the different parts of the formula. You have to be able to use a calculator with a power key to find the present value. And of course, we want you to, again, separate the interest in that account from the principal and the compounded amount. Now, present value is a little bit different. In most situations that you're going to deal with monetarily, you are going to be aware of the goal amount. You will know that you need $30,000 for a home renovation or $4,000 for a vacation. What you might not be aware of is how much money you need today, the present value of that money, so that you have the funds available to you for your future goal. Now, it is worth noting that in today's presentation, what we're talking about is not squirreling money away in a savings account. We're not putting money away every week or every month. We are instead considering it as a lump sum. We want to put away a lump sum of money and then forget about it. So this is more of a set it and forget it than it is a squirrel some money away in little increments over 3 years. All right? Okay, so to calculate that present value, we are going to be using the present value table. You should be able to see them just fine. The last section is 11.8, and this is the formula for finding present value. Now, our formula for finding present value is a rearrangement of the compound interest formula, and it says that the present value is equal to the amount, that's your goal amount or compounded amount, divided by 1 plus I. I wonder, how did that happen? 1 plus I, interest rate per period, to the nth power. 1 plus I to the nth power. Yep, we're going to need to switch that up. Okay, so everything's the same. Your I, or interest rate per period, is the stated interest rate divided by the number of periods. Your N is the total number of compounding periods. That's the compounding periods in 1 year times the number of years. Present value is the amount you're going to have to put in. That's what we're looking for here. And A is the goal amount or the future value. This is the future value or the goal amount. How much will it be worth? All right, so let's try a problem. Here we have Max and Tim, who will have a balloon payment of $42,000 to make on their mortgage in the next 15 years. How much do they need to put away today at 3.3% interest, compounding monthly, in order to make that payment? Now, I know I have to use the formula on this one instead of the tables because my interest rate is not a whole percent. Pretty much every time we've used the table, our interest rates have been whole numbers, 4%, 5%, 7%. The exceptions would be 0.5% and 1.5%. But there's nothing in the table for 3.3. So I'm going to have to use the formula here, and I know it because my interest rate is a decimal. My interest rate per period is going to be the same as it has always been. I is going to equal the annual interest rate divided by the number of compounds per year. The one little sneaky part of this one is because you are putting this into a formula, and using your calculator, you must calculate the interest per period as a decimal. So I'm going to take 3.3% and put it in as 0.033, or divide 3.3% by 100, or if you'd rather, move your decimal point 2 places over to the left, however you remember it. So 0.033 divided by 12 is 0.00275. My N, or total number of compounds, is going to be 12 times a year for 15 years. That's 180. That means I can substitute the I of 0.00275 and the N of 180 into my formula, knowing that the goal amount here is $42,000. So the present value is that goal amount divided by 1 plus I to the N, or 42,000 divided by 1 plus 0.00275 to the 180th power. I'm going to do the denominator first, or 1.00275 to the 180th power. So I have 42,000 divided by 1.639384096. Now, if you're calculator savvy, you can do all this in sort of one entry. If you have an older calculator, if you're not calculator savvy, you're going to need to do this piece by piece. If you're doing it piece by piece, please retype as much of that number as you can, because the bank is going to eke every penny out, and so they don't round. And if you just divide by 1.6, you're leaving a whole bunch of money on the table. You really are. Try it. See if there's a difference. And there is. All right, so we're going to take that 42,000 and we're going to divide it by 1.639384096 to get $25,619.37748. Rounding everything to the nearest dollar amount, we get $25,619.38. What does this mean? Well, I don't know if you're familiar with a balloon payment in a mortgage, but we'll just give you a little bit of finance information here, just a quick overview. So when you do a mortgage, you generally make regular payments, right? Monthly or whatever. If you choose a mortgage with a balloon payment, basically what you're saying to the bank is, I want you to artificially lower my mortgage payment. So instead of paying $1,200 a month, you're only going to pay $1,000 a month. And those $200 payments that you're missing, you're going to catch up in 15 years with a bulk payment of $42,000. That's essentially what a balloon payment is on a mortgage. They artificially lower your monthly payment, and then at some point you have to catch up. Maybe some of you are like me, and I'm on, for my electrical bill, I'm on the budget. I'm on the budget system, so I give them the same amount every month. And then for me, in October, I have to catch up. So if I'm paying them, say, $96 a month, but by October, that's not enough, I still owe them money, because some months I actually owed them more than $96. Then October is my catch-up month, and I make the balloon payment in October, having to pay off anything that was under the rest of the month. That's sort of the idea here with this mortgage and the balloon payment, okay? So they need to put away $25,619.38 today. And if they have that money and they can put it away in an account at 3.3% interest for the next 15 years, then in those 15 years, that money will grow to be the $42,000 that they need to pay it away. You can see that this is savings, right? Because instead of paying $42,000, they're instead paying $25,000, saving themselves almost $20,000 off of their mortgage. So if you have the wherewithal to do it, you're saving yourself money in the long run. It's not always the case. Here we have a problem where Barb and Eddie are planning a road trip on Route 66 in the next 3 years. This is actually something people I know have done that for their 66th birthday. They got a bunch of people together and traveled Route 66. It's super cute. All right. They estimate that $8,000 should cover their expenses. That's the rental, the hotels, the whole thing. How much should they place in an account earning 4.2% interest, compounding quarterly for the next 3 years in order to have that $8,000? So we're going to do the same sort of process here. We're going to find the interest rate per period. Since it's a 4.2%, I know I can't use the table, so I'm going to do my interest rate as a decimal, 0.042, dividing by 4, because it's compounding quarterly, and I'm going to get 0.0105. Total number of compounding periods is 4 times a year for the next 3 years, so 12 compounding periods. My goal amount, or Barb and Eddie's goal amount, is $8,000. So I'm going to substitute these values into the formula, the goal amount being 8,000, my interest rate, or I, per period being 0.0105, and my total number of compounds is 12. So this becomes 8,000 divided by 1.0105 to the 12th power, or 8,000 divided by 1.133537297. This turns out to be $7,057.55. So in this particular problem, the amount of interest that they're earning is not quite $1,000. So if they want $8,000 in 3 years, they have to be able to put $7,000 and change aside today. That doesn't seem like as big a savings. Like over the course of a year, I could probably save $1,000 maybe, or find a better use for it. But you can see it's still a savings. It's just not always as impactful. In order to be impactful, your savings needs time and a higher interest rate. So the difference between 3 years and 15 years is quite a bit of interest. As I have with the last 2 sections, I also have a slide here with just some calculator practice. The formula, again, is present value is equal to A divided by 1 plus I to the N. This finds you the present value, or the principal that you should put down. I'm going to click through this guy, maybe do a couple of examples. If you want to have $6,000 and you have 3 years and a 9% interest rate compounded monthly, keeping in mind that monthly means you have 12 compounding periods, we're going to take the interest rate as a decimal, 0.09, divide that by 12 to get 0.0075. This is our interest rate per period. Total number of periods would be 3 years times 12 times a year, or 36. The formula would be the goal amount, or the compounded amount, or the future value, divided by 1 plus I to the N, or 6,000 divided by 1 plus 0.0075 to the 36th power. If you do this, you should get $4,584.89. If you would like to have $50,000 and you have 25 years, okay, it's a lot of time. So my present value should be relatively small compared to the $50,000, because the more time you have, the further away from your goal amount you can go. All right, we've got 5.2% compounding quarterly. Quarterly is 4 times a year. So I'm going to take 0.052, because I'm putting it into a formula, divided by 4 to get 0.013. Total number of compounds is 4 times 25, or 100. Present value formula is the goal amount divided by 1 plus I, interest per period, to the nth power, or 50,000 divided by 1 plus 0.013, to the 100th power, and I get $13,741.23. Compared to the $50,000, this is very little, right? $50,000 versus 13 or 14 almost. But you got 25 years to grow. 25 years for the money to grow. And when you have a lot of time, you can start with a smaller amount of money. All right. These last 3 problems here, I'm just going to click through this next one. And then I'm going to make a point on this one that's $500,000. Here we have I would be 0.03 divided by 365, or 0.0000. It's 4 of them, right? 82192. This is a very awkward number. Sometimes when these numbers don't work out very well, when you get a lot of zeros in front of it or when it doesn't divide out and terminate, it's actually better to type it into your calculator just as 0.03 divided by 365. That would be an absolutely fine way to type it into your calculator, and that would not cause an issue at all. All right. So I'm going to leave you here with this last one. I am, of course, blocking the answer, but you should get $22,902.74. That's all there is for section 11.2. It's a lot of rehashing. It's just being able to know the difference between present value and future value. Unfortunately, the processes stay very much the same. So at this point, do you feel like you can determine the present value of a future goal? Can you do so using the present value table? Are you fairly confident in finding the interest rate per period, the total number of compounding periods, and calculating present value? Not only that, but are you able to identify the interest and the principal and the compounded amount? Can you calculate a table factor beyond what's given to you in the table? And are you comfortable using the present value formula? That means, are you able to identify the parts, and can you use a calculator itself to determine what that present value would be? And not only that, but can you once again separate the compounded amount, future value, the goal amount, all three of those are the same thing, from the interest and the principal? There is extra practice for this section in your e-text at the end of Chapter 11, Section 2. The review exercises are, I believe, 1 through 29. If you have a physical copy of the textbook, you can find this information on pages 358 to 360. I'm sorry, it's not information. You can find these practice problems on pages 358 to 360. There is a graded assignment available on WebAssign. It is creatively labeled Chapter 11, Section 2. If you have any questions or concerns, please don't hesitate to reach out to myself, to your embedded math support, to the Math Center, or to a tutor that you may have available to you. We want to see you succeed. We are all here to help. Thank you.